Check out these amazing space news stories from this week. I hope you enjoy this edit. Don't forget you can catch each of these stories in a daily short on YouTube, and please consider subscribing and sharing this content if you enjoy it. iSpace's Resilience lander failed to reach the lunar surface last week, the second failure for its Akuto-R platform. Once again, communication was lost with the lander during the descent phase, and after several hours of trying to raise the Resilience lander, iSpace concluded the mission had suffered a hard landing. iSpace suspects the laser system that measures the distance from the craft to the lunar surface as it descends and ensures a soft landing failed. If that's the case, it would be the same failure mode as the previous attempt, and I'm sure that'll be deeply disappointing for the iSpace engineers. The lander also carried a small rover that would have sampled lunar soil and a range of other science experiments that are now lost. Landing on the lunar surface is notoriously difficult, with only 5 nations pulling off the feat successfully and 1 private company. Only the US has successfully put humans on the moon, and private companies have had way more failures than successes. The cost of the mission is not known, but the previous iSpace lunar mission cost in excess of $100 million, and it's not clear how many more attempts the company can support. As I mentioned in last week's video, iSpace's US subsidiary has a contract with NASA to deliver a payload to the lunar surface in 2027, and it's very unclear how this latest failure affects their ability to deliver on that contract. Scientists from the Southwest Research Institute may have an explanation for why solar systems around other stars don't look like our own solar system. The inner part of our solar system has relatively few and small planets in it, just 4 out to the orbit of Mars. As an example, the TRAPPIST-1 system contains 7 planets that are all within 9 million kilometers of the central star. That's super close. For reference, our innermost planet, Mercury, is 58 million kilometers from the Sun. There are hundreds of other systems like TRAPPIST-1, and one odd fact that keeps coming up is that the ratio of the total mass of the planets in these compact systems to the mass of the central star is very constant. For the most part, we've assumed that planetary formation begins after the star formation process ends. A molecular cloud of gas and dust collapses under its own gravity to form the star, and the planets then form from the leftover debris disk. However, the researchers have used numerical simulations to show that planets may begin to form much earlier during the formation of the star, whilst it still experiences an infall of material. As the young planet gains mass, it will start to spiral in closer to the star. A fine balance is needed because if the planet becomes too massive, it'll spiral right into the star and be consumed. But the simulations show that not only do some of the planets survive, but that they end up in this very compact orbits that we observe in systems like TRAPPIST-1, and the ratio of mass in the planets to the mass in the star is also consistent with the observations. This super interesting look at the formation of compact planetary systems was published May the 25th in the journal Nature Communications. Sicily's Mount Etna erupted on June the 2nd, and ESA's Copernicus Sentinel satellites were there to capture the event from space. The first image that you can see here is an optical image from ESA's Copernicus Sentinel-2. The huge plume of ash, gas, and rock is clearly visible in the image, along with a significant lava flow. According to reports, the eruption caught tourists by surprise and sent many racing for cover. The second image is from the Copernicus Sentinel-5P mission that captured the huge sulfur dioxide emissions from the eruption of Europe's largest volcano. Until June the 2nd, Mount Etna had been quiet since its last major eruption in 2014. Scientists report that the northern flank of the volcano's southwest crater has partially collapsed. This imagery shows the huge value there is in having a fleet of active Earth-observing satellites up there to give us all this great information. Let's talk about how the proposed cuts to NASA's budget could affect space exploration and astronomy if they're passed. ESA announced at a press conference today that at least 3 large joint space missions will be threatened by the budget cuts. LISA, a space-based gravitational wave detector that will study black holes and binary stars to test Einstein's theory of general relativity and was expected to be operational by the early 2030s. Envision, a mission to orbit and study Venus in detail. And New Athena, the largest ever X-ray observatory that could continue the legacy and amazing science done by the Chandra X-ray Observatory. These missions have been in planning and development for at least 10 years, and ESA said that the proposed cuts to NASA would mean the missions would either have to be frozen or possibly cancelled. A further 16 joint missions would be affected by the cuts, but ESA sees ways of mitigating some of the damage there. The effect on multiple NASA missions has been documented elsewhere, but today the director of the National Solar Observatory announced at the American Astronomical Society meeting in Alaska that the world's most powerful solar telescope, the Daniel K. Inouye Solar Telescope, or DKIST, would no longer be able to operate if the current budget request passes. The observatory cost about $30 million to operate this year, and the director said there's no way to operate such a complex facility on the $13 million that's proposed for 2026. The telescope was 25 years in the making and only came online in 2020 and represents the best ground-based tool we have to study our star. These are just a few of the impacts of the proposed cuts, and there are many, many more. The Planetary Society has done a great job of cataloging the impacts, and I recommend heading over to their website if you want to learn more. I don't think anybody would argue that we shouldn't try to be as efficient as possible with taxpayer dollars and review what we're spending on science in the US, but the kind of random wholesale cuts to NASA and all the other science that are being proposed make absolutely no sense to me. I hardly need to say this, as I'm sure you're already on your way down to the comments, but please let me know what you think below. I was in San Diego recently, and the beaches were closed due to high levels of bacteria from pollution. What shocked me was that I hadn't heard about the decades-long pollution crisis that's led to these closures. The problem is long and complex, but the short version is that rapid urbanization and population growth in Tijuana has overwhelmed already inadequate sewage treatment plants on both sides of the US-Mexico border and resulted in billions of gallons of untreated sewage and industrial pollution being released into the Tijuana River and from there into the Pacific Ocean. Obviously, this has a massive negative effect on the river, the people and wildlife living in the area, and the marine ecosystem. It's now so bad that scientists are worried about aerosolized bacteria getting people in the region sick, even if they don't go in the water. Okay, so what does this have to do with space? Well, scientists at NASA's Jet Propulsion Laboratory have come up with a way to help track contaminants in the water using an instrument called EMIT that's mounted on the International Space Station. Originally intended to map minerals and dust across the Earth's deserts, the scientists used EMIT to image the Tijuana River estuary and its outflow into the Pacific Ocean and went through it pixel by pixel. They found that they could identify molecules that were present in the water, including a marker for cyanobacteria that makes people and wildlife sick. They cross-referenced their findings with water testing that was performed in the area of each pixel and confirmed that their results agreed with the results from the testing locations. What's super cool about this is that EMIT can be used to effectively monitor a much larger area than can be tested by hand and can also show areas of high pollutant concentration that are currently not being tested. Huge props to the scientists that were able to use an instrument designed to measure dust on land to help out with an urgent pollution crisis in the water. If you want to learn more about the story behind the Tijuana River pollution crisis, I've included a link in the description to get you started, and there's also a link to details on the EMIT instrument.